In this video, we'll be discussing the chords and segments of a circle. A chord is a straight line that touches the circumference of a circle at 2 points, like we can see here. And the diameter is also a chord. It's a special chord, the longest chord in the circle. It passes through the center of the circle and then touches the circumference of the circle at 2 points. Now, a chord divides a circle into 2 segments. So for a chord that is not a diameter, it divides it into a major segment and a minor segment. Minor being the smaller one and the major segment being the bigger one, the bigger segment. And since we'll be looking at the perimeter and area of a segment, it's important that we start by knowing what is the length of a chord. How can we find the length of a chord? Okay, so if this is the center of a circle and this is the chord, so we have this line. So this is a radius because a radius is any line that comes from the center of the circle and touches the circumference. So this is a radius. This is also another radius, r. And then this is the angle subtended by this chord, theta. If we have to have a line that passes through the center of this circle and touches the chord, any line that passes through the center of the circle and touches a chord is perpendicular to that chord, and it also bisects, that divides the chord into 2 equal halves. So for the length of this chord, let's call this part x and let's call this part x. So x plus x is equal to the length of the chord. Now, if we look at this triangle, we can see we have formed a right-angled triangle with the hypotenuse, that's this side, opposite angle 90 as the radius of this triangle. And we can see that this line that cuts this triangle into 2 is, that's the angle here is theta over 2. So we have that, we have opposite, we have hypotenuse, so we are using sine. We have sine theta over 2 is equal to opposite, which is x, half of the length of the chord, times r, which is the hypotenuse. Making x the subject of the formula, we have that x is equal to r sine theta over 2. And since x is just half, therefore, the length of chord is equal to 2 times the whole thing, 2r sine theta over 2. Now we'll head over to example. Here we have that a chord of a circle of radius 8 cm subtends an angle of 60 degrees at the center of the circle. Find the length of the chord. So if we could have that pictorially, we have this and we have this subtend 60 degrees. So the radius is 8 cm, subtend 60 degrees, and this is the chord. We are told to find the length of the chord. And from what we know previously, we know that length of chord is equal to 2r sine theta over 2, where we have that r is 8 cm and then theta is 60 degrees. So angle at center, we substitute that. When we substitute, we have 2 times radius, which is 8, times sine 60 over 2. Okay, we have 2 times 8, that is 16, times sine 30. And from what we know that sine 30 is half. Let's look at it again. So this is our palm and this is angle 30. So root of the angles below, root 1 over 2, which is 1 over 2. We have 16 times half, which is 8. So the length of the chord is 8 cm. In this example, we have that a chord of a circle of radius 3 cm subtends an angle of 60 degrees on the circumference of the circle. Find the length of the chord. Okay, so let's have that pictorially. We have a circle and we have that the radius of this circle is 3 cm, an angle of 60 degrees. So this angle is subtended at the circumference of the circle, not at the center of the circle. So we have a particular angle subtended at the circumference of a circle, which is 60 degrees. So when we complete this is another radius, and therefore this is now the chord. As strange as this looks. Okay. So, and remember that angle at circumference is equal to, that's angle at center is equal to 2 times angle at circumference. And if that be the case, so length of chord is equal to 2r sine theta over 2, meaning that theta, angle at center, is equal to 2 times this angle at circumference, 2 times 60. Okay, that's 120. We have 2r, 2 times 3 sine 120 over 2, which eventually lands us to 60. So 2 times 3, that is 6 sine 60. And then sine 60 degrees is equal to 6 times root 3 over 2. Yeah. So we have it's equal to 3 root 3 cm. That's the length of the required chord, in which you use calculator to find the actual number. A chord 70 cm long is drawn in a circle of radius 37 cm. Calculate the distance of the chord from the center of the circle. We are going to have a diagram. We have this chord. It's 37 cm in length, and we have the center of the circle. We have that the radius of this circle, the chord is 70 cm in length, and the radius of the circle is 37. So we've been asked to find the length of the chord from the center of the circle. So that is this. Okay, so all we have to do is we are going to draw out this triangle. Remember that this length is at right angles to the length of the chord. So we are going to draw that out. We have 37, and this is the required length we are looking for, and this is half, 35. So all we have to use is Pythagoras theorem. We have that 37 cm squared is equal to 35 cm squared plus L squared. Making L the subject of this formula, we have 37 squared minus 35 squared. We are going to use difference of two squares to make this easier for us. So 37 plus 35 into 37 minus 35. We have that these two adding up together is 72. 72 times 37, that's 2. So 72 times 2 is 144. Remember, this is equal to L squared. So we are going to get the square root of both sides, and we have that L is equal to 12 cm. So the distance of this chord from the center of the circle is equal to 12 cm. Now that we have found how to calculate the length of a chord, now let's get into segments itself. So this is the chord and this is the minor segment. If we are told to calculate the area of this segment, what we have to do is to calculate the area of this sector that the chord subtends, that has this angle here, and then we subtract the value of this triangle here, because that's the difference between this segment and this whole sector. So in formula form, what we are going to have is that the area of this sector is theta over 360, right, times pi r squared. That's the area of the sector, minus that's the area of this triangle. Now for this triangle, we have two lengths and an included angle. So we go by this formula. Half of the lengths multiply each other. So r square sine theta. So, wow, that's huge. But now let's look at examples to see how to use this. Here we have this circle with radius 7 cm, and we can see that the angle subtended by this chord is 90 degrees. You can see that corner. Whenever you see this corner, you don't need any other information. And we've been asked to find the area of this shaded region, so the area of this minor segment. So what do? We write out the formula. So theta over 360 times pi r squared minus half r squared sine theta. So that's just it. Okay, so this is the area of this sector. This is now the area of this triangle. We have the theta itself is 90. The angle is 90 over 360 times pi, which is 22 over 7 times r squared, which is 7 times 7. All this minus half r squared, 7 times 7 sine 90. Okay, 7 cancels out 7. When these two divide each other, we have 4. And this is 2, 11. So 77 over 2, that is what we have here. 77 over 2 minus sine 90 is 1. So what we have here is 49 over 2. So we have same denominator. So over 2, 77 minus 49. And in which we have that is equal to 28 over 2, which is equal to 14. So since that's area 14 centimeters squared, that's the area of this segment. So we can see it's easy. It's just important for us to memorize this formula, recognize this part, and we are good to go. Okay, from this question, what if we were asked to find the perimeter of this segment? What would we have done? So the perimeter of this segment is the length of this minor arc plus the length of the chord. That was why it was important for us to learn how to calculate the length of the chord. Now let's calculate the length of chord. Length of chord is equal to 2r sine theta over 2, right? So that is 2 times 7 sine. Theta is 90, so theta over 2, that is 45 degrees. Okay, we have that as 14 sine 45. This is 45, so root 2 over 2. Let's have it as root 2 over 2. So 2 into itself is 1. So all we have left is 7 root 2 as the length of that chord. Let's just leave it like this, since we don't want to use calculator to solve. Okay, then the length of this arc. Remember that length of arc is equal to the angle subtended by that arc over 360 times the length of the circumference of the circle. That's the circumference of the circle, 2 pi r. So for this case, we have 90 over 360 times 2 times 22 over 7 times r, which is 7. 7 cancels itself. This cancels to give us 4. And then this 4 cancels these 2 to give us 11. So the length of the arc is 11 cm. Therefore, perimeter of segment, perimeter of the whole segment is equal to the length of the chord, 7 root 2 plus 11 cm. So since this involves this, we can't add it up like this. We have to get the actual value for this and then add it up to 11. But if we were to leave the answer in short form, it is just this. It's not, we can't add 11 to 7. No, this 7 has something attached to it that we can't add up 11 to. So that is it about segments and chords.